Hi, so today we're going to be going over the first 6 questions of the review sheet for Unit 7. So let's start right out. Number 1, we have a differential equation, y double prime minus 4y equals 0. We're going to be determining which of these 4 is a solution. So I'm just going to start right out with the first one. So the differential equation says that I need the second derivative, so I've got to go and find the second derivative of each of these, but I'm just going to start with the first one and check it, because if that's the answer, I don't have to check the rest. So the first derivative for the first one is, this is a chain rule, so the derivative of the inside times the derivative of the outside. And then the second derivative, again, chain rule, derivative of the inside, which is 2, so times 2 is 4, e to the 2x. Now I'm going to plug back into this differential equation and check my work. So the differential equation says y double prime, which is 4 e to the 2x, minus 4 times y, which is e to the 2x, equals 0. And if I clean this up a little bit, that does in fact equal 0. So A is the correct solution. I don't have to check the rest, which is kind of nice. Okay, let's move on to question number 2. Number 2 says, let g be a function such that g of y is greater than 0 for all y. Which of the following could be a slope field for the differential equation dy dx is equal to x squared minus 1 g of y? So what I've got to do here is test some points. So I know it's a pain because we have slopes on multiple pages. So I'm just gonna look, I looked through these and decided like a quadrant to start in, and then you can kind of narrow down some solutions. So let's pick a point. I'm going to pick a point in, I'm going to start with a point negative 1, 1. So that's in the second quadrant. So if I map it on this graph right here, it's about right here. So on this first graph, that's a slope of 0. So let's just plug this in and see what we get. M equals x squared minus 1, so that would be 1 minus 1, so 0. So it works for A. Let's check on the second graph. B, negative 1, 1. Yep, I got a 0 slope there. On the C graph, negative 1, 1. Yep, I got a 0 slope there. Oh, but this graph, D, I do not have a 0 slope, so D cannot be the solution. I can cancel that right out. Less to look at. Okay, so let's go back. I'm going to check, if I check, like, some of these are different on the y-axis, so I'm going to check 0, 1 next. So the slope at 0, 1, if I plug into my formula, would be 0 minus 1, so negative 1. So A could be a solution, right? At 0, 1, I have a slope of negative. It's a negative value. B, it's a positive value, so I can cross B out. And C, at 0, 1, I have a 0 slope. I can cross that one out too. So my final solution should definitely be A. And that's not bad. I got that after just checking 2 points. Okay, so moving on to question number 3. Number 3 is very similar to the last one. Which of the following could be a slope field for the differential equation dy dx is equal to x squared plus y? So I've got a bunch of graphs to look at. They're again all on different pages, so that's kind of a pain, but I'm going to do the same thing. I'm going to be checking points in different quadrants and just comparing and canceling out what doesn't work. So I'm going to start with a first quadrant point, and it doesn't matter where you start. I'm going to start at 1, 1 and get my slope at that point. So 1, 1 would give me 1 plus 1, so 2. So I'm going to cross out anything that doesn't have a positive slope at 1, 1. So let's look at A. A at 1, 1 has a positive slope, so that one's okay. B at 1, 1 has a negative slope, so B I can cross right out. C at 1, 1 has a positive slope, so I'll leave that one alone. And then D at 1, 1 has a positive slope, so I got rid of one. So let's go back to a next point. So I'm going to test 1, negative 1 next. So that's a fourth quadrant point. And if I plug that in, I get 1 minus 1, so the slope is 0. So I'm going to check 1, negative 1 and see if the slope is 0. So let's check A. 1, negative 1, yep, I got a 0 slope, so A is still good. We already crossed off B. C, 1, negative 1, oh, I've got a positive slope there, so I can cross off C. And D, 1, negative 1, I got a 0 slope. So now we're between A and D. Okay, so I'm going to check a second quadrant point, negative 1, 1. So let's see here. I'm going to plug this in. I got 1 plus 1, so the slope is 2. So let's look at A. For negative 1, 1, oh, I have a 0 slope there, not 2. So I'm going to cross off A, and let's just double check D. Looks like that's going to be the answer, but I'm going to double check it just to make sure I didn't make any mistakes. So if I look at D, negative 1, 1, yep, it looks like I have a slope of 2 there. So D is the solution. Okay, on to number 4. Now number 4 is a little bit nicer because the slopes are at least all on one page. So I'm going to just work through the same thing, and I'm going to test some points in different quadrants. So this time we have x squared plus y squared. So looking at the graphs, first I kind of find a point that maybe they're all a little different. So I'm going to start with negative 1, 1, so something in the second quadrant. So negative 1, 1, if I plug that into my slope formula, that gives me 1 plus 1, so the slope is 2. So I'm going to check all of these here. Negative 1, 1, that one's okay, that's a positive slope. Negative 1, 1, that's a positive slope. Check C and D. Negative 1, 1, which would be way up here, but I can tell that's going to be negative, because all the slopes there are negative, so I can cross off C. Negative 1, 1 has a positive slope, so I've gotten rid of C. Okay, next up, let's check 1, 1. 1, 1 would also give us a slope of 2. So let's go to our graphs. Let's check the first two. 1, 1 is a positive slope. Here it's a negative slope, so I can cross off A. 1, 1 is a positive slope, and down at D, 1, 1 is a positive slope. So we're between B and D at this point. Okay, so looking at B and D, I'm going to find a point where they're definitely different, so I can just check one last point. So if you look at 0, 1 on D, we have a 0 slope. And on B, 0, 1 gives us a positive slope. So I'm going to check 0, 1 next. 0, 1, the slope is 1, not 0. So that means it can't be D. It's got to be B. Okay, let's move on to question number 5. Question number 5, we have a slope field given to us, and it says the slope field for a certain differential equation is shown above. Which of the following could be a solution to the differential equation with the initial condition y of 0 equals 1? So they give us a point, and I'm going to plot that right here is 0, 1. So if I had to draw a graph of that, something like that. So they give us the original problem. So which original problem would look like that graph? So let me just look at what they give us. Cosine can't be a solution, right? Cosine looks like this. 1 minus x squared, that's an upside down parabola, which does not look like my graph. E to the x is an exponentially increasing function, so that's not my solution. D is a square root with an x squared. That's actually a semicircle, which does not look like D. So if I don't know anything about what E is, because I've narrowed it down to it can't be the other four, it's got to be E. But if you were to graph that, it would look exactly like that function. But another thing to note, this would be a non-calculator question, so you wouldn't be able to check that on your calculator, so that's exactly how you would do it. Cross off the ones that don't work. Okay, last question, so let's go on to question number 6. Number 6, a student attempts to solve the differential equation dy dx equals x to the third with the initial condition that y equals 2 when x equals 0. The steps of the student's solution are shown below. In which of the following steps does an error first appear? So first thing I'm going to do is I'm just going to do my own work here. Dy dx equals x to the third. I'm going to cross multiply. And I'm going to take the integral. That would give me y equals 1/4 x to the fourth plus c. I'm going to stop there just to check my work here. So, I see that it does not match already. So it looks like they separated the variables wrong right at the beginning because I don't even have what they have. So it's actually step 1 is the first mistake. Now, when I was looking at this, I noticed that step 2 also has a mistake. So what I think happened with this question is that there's a typo in the question. I think the original question should be, so you don't have to worry about this because we picked the right answer, but I think the original question is dy dx equals xy to the third. So I'm just going to finish this to show you how they made this mistake in step 2. So I'm going to cross multiply. Move that y to the third over. Now that gives me their step 1. So now if I take the integral, I'm going to rewrite this as y to the negative third dy. And then I'm going to take the integral of both sides. So I'm going to add and divide. So that gives me negative 1/2 y to the negative second. And this gives me 1/2 x to the second plus c. So according to this, if the answer was given correctly, step 2 would be the mistake because the integral of 1 over y cubed is not an ln. ln is only if you just have 1 over y. So that's just something to think about because I think this one had a crazy mistake in the beginning. So according to the mistake, our answer should be step 1. But if we fixed it to match the actual work, the mistake is in step 2. Okay, that concludes our video for today.